Hello, today I'm going to introduce igneous rocks. First, there are two types of molten rock, lava and magma. Lava is extruded and cooled onto Earth's surface from volcanoes, where magma cools below Earth's surface. Four types of composition. First is Felsic. It contains high amount of feldspar and quartz. It is light-colored, usually pink or white. The name comes from high feldspars and SilICa. Examples are granite. On the left is red granite, and on the right is white granite. Both are granite. You can see the quartz and feldspar in the left sample. Another granite sample. Rhyolite is also Felsic. You can see individual shiny quartz particles. Here is another example of a rhyolite. Second, intermediate. Middle composition between Felsic and Mafic. Gray color. This is an example. Diorite is intermediate. You can see the light Felsic part and the dark Mafic part interlocked together. Another example, Porphyritic Andesite. Andesite is also intermediate. Third, Mafic. High amount of pyroxene, amphibole, and calcium-rich feldspar, dark near black color. The name comes from high magnesium and iron, which is ferric ion. Example, Gabbro. You can see the dark minerals. Basalt. Vesicular basalt. Vesicular, which means gas bubbles. Scoria. Fourth, ultramafic. High amount of olivine and pyroxene. Very dark, commonly green due to olivine. This table shows the relationship between composition and the contents of different elements. From Felsic to intermediate to Mafic to ultramafic, the content of silica is decreasing and the iron and magnesium is increasing. The density is from low to high and the color changes from light to dark. This can help you to identify the composition. Composition is also related to the violence. Felsic and intermediate lavas are more explosive because it has higher viscosity, which means it's harder to flow, while Mafic and ultramafic are much less explosive because its lower viscosity means it's flow easily. Volatiles, which is water and carbon dioxide, increase the explosiveness, and the explosive volcanoes form at subduction zones. Bohr's reaction series means an order of crystallization if a magma chamber cooled it down without interruption. Igneous rocks textures. There are 6 textures depending on the cooling speed and whether or not it is cooled from magma, lava, or ash. Underground magma cools slowly, causing larger crystals, while surface lava cools quickly, causing smaller crystals, or contains vesicles, which is gas bubbles, and surface ash has pyroclastic texture. First, FerrIC means minerals coarse enough to see with only your eye. Examples are granite. You can see individual grains. Diorite. Individual grains are visible. Gabbro. Coarse grains. Second, aphanetic. Minerals too fine to see with the naked eye need hand lens. Examples: rhyolite, fine-grained, basalt, andesite, Porphyritic. Larger minerals set in a fine-grained matrix, which is the material between grains. Porphyritic andesite. You can see the individual dark minerals set in the fine-grained matrix. Vesicular contains gas bubbles, which is vesicles. Pumice. You can see the gas bubbles. And notice that it is very light. Vesicular basalt, which is basalt contains gas bubbles. Scoria, very light. Fifth, glassy, looks like glass. Caused by rapid cooling, no crystal structure, no grains. Example, obsidian. Finally, pyroclastic, fragmental texture composed of larger pyroclasts, which are clasts of lava, pumice, and country rock, in a matrix of volcanic ash. The rock has this kind of texture is made from ash. Example, volcanic tuff. You can see black pyroclasts in ash. Use texture and composition to identify samples. These three samples are coarse-grained, which means they belong to FerrIC texture, and we arrange them according to their composition from Mafic to Intermediate to Felsic. From this table, we find that with their composition and their texture, these samples are identified. Thanks for watching. I hope this helped. This is a showcase of some igneous rocks arranged according to their composition and textures.